Okay, in this math 2, we're going to do 61, 62, and 60, what did I say? Whatever, 66. Okay. So, in the first one, it says enlarge the shape from the origin, so using the origin 0, 0 as a point of dilation by a scale factor of 4. So, they just give you this little tiny piece, and that's not very convenient. So we're going to have to do this on a big piece of paper because this is going to get not too big, but it's going to get a little bit bigger than normal graph paper that I use. So right now all I'm doing is I'm recopying the shape. So if you want to press pause and fast forward, you're more than welcome to. But I gotta copy this out. What does this look like? -2 here, here, here. So this is a Star Trek symbol. I'm pretty sure this is the Star Trek symbol. Okay. There we go. That's the original. So we're gonna go dilate by a factor of 4. Or we're going to do it by 4 rubber bands. This is going to get pretty big. So let's go with one corner first. So from the origin, right, if I'm over here, and I'm going to use this point right here, I'm going to say, okay, I'm going to go from here. If I shine the flashlight out, right, this point right here is just going to go 1. So this is 1 rubber band, that's 2 rubber bands, 3 rubber bands, 4 rubber bands. Okay, that works out. Same thing here, 1 rubber band, 2 rubber bands, 3 rubber bands, 4 rubber bands. All right, I guess we can call this A, B, C, D. So we're going to call this C prime, and we're going to call this A prime. All right, now let's go with point D. This is 1 rubber band from here to here. Then I'm going to go another 3, that's 2 rubber bands. Another 3, that's 4 rubber bands. I'm sorry, that's 1 rubber band, 2 rubber bands, 3 rubber bands, and 4 rubber bands. Right? So 1, 2, 3, 4. Okay, there's D prime. And now this is B prime. So we're going to go rubber band, 2 rubber bands, 3 rubber bands, 4 rubber bands. All right, there it is. We just got to connect them. So it will look like, a different color. Let's go with fuchsia. It should look like that. Okay, and we're good to go. So there's your new shape, and it was blown up by a scale factor of 4 or dilated by a scale factor of 4 from the origin as your point of dilation. Okay, that was what? 61. Okay, 62. We have the ratios Casey wrote from part A of problem 5.2-58 ratios for the length of the corresponding sides of 2 shapes. Look at the similar triangles below, which sides correspond. Write the ratios for the corresponding sides. Okay, so we're going to do that first. So we have 15 and 6, because those are in the same spot in between the same 2 angles. And we have 20 and we have 8. So we're going to do the ratios for them. I'm trying to figure out how they want this to do, but I'm assuming 15, 6, 20, and 8. All right, so here we go. 15 over 6, and then 20 over 8. And let's see if it simplifies to the same thing. So 15 over 6 is the same as, what do they both have in common? 3, right? So 15 divided by 3 is a 5. 6 divided by 3 is a 2. All right. So we have 5 over 2. And then 20 over 8, they both have a 10 in not a 10, a 2 in common, definitely, but I think they both have a 4 in common also. So 20 divided by 4 is going to give us a 5. 8 divided by 4 is going to give us a 2. And lo and behold, the ratio is the same, 5/2. All right, well, that takes care of the 2 legs of the 2 right triangles. The question is, calculate the length of the hypotenuse for each of the triangle. Is the ratio of the hypotenuse equal to the ratio you found in part A? So by now, you should be pretty adept at figuring out what the hypotenuse is of a right triangle. Okay, and then is it, well, you're gonna have to do the hypotenuse for this one, and you're gonna have to find the hypotenuse for that one, and then do the same thing that I did for part A, which is set up the ratios, the one on the left hand side over the one on the right hand side, and see if you can simplify it to 5/2. All right, is the ratio equal to the ratios you found in part A? So you're gonna have to say yes or no once you find it. And then describe a sequence of transformations that maps one triangle to the other. So how did you go from this one to this one? And well, a dilation is sort of like a transformation. Well, just describe what you can for that one. And then the last bit is number 66. Renee's MP3 player can be programmed to randomly play songs from playlists without repeating a single song. And currently her MP3 player has 5 songs. And then we're back at least this time we don't have a bunch of mamas to take care of. Has 5 songs loaded, which are listed at the moment. She only has time to listen to 1 song. Oh, wow. Okay, well, she's not going to do 2 songs. She's just going to do 1 song. Is each song equally likely to be chosen as the first song? I would say so, yes, because I don't see any duplicates here, so I think we're good to go. What is the probability that her MP3 player will play a country song? Okay, well, there's only 2 country songs, right? So that would be 2 out of, and she only has time to listen to 1 song, right? So we only have 5 in our sample space. Because in the previous one, we had sample spaces with, she had the opportunity to listen to 2 songs. So the bottom number was not going to be 5. And the question is, what is the probability that she listens to a duet with Hank Tumbleweed? Who's Hank Tumbleweed? Oh, here we go. Hank Tumbleweed. Is that the only one? Yeah, there's only 1. Okay, so that would be just 1 out of 5. And then the next question is, what's the probability that she'd listen to a song that is not, very specific, not R&B? So if it's not R&B, it could be pretty much anything. And then that number out of 5. And that's it for this homework assignment.